this computer. Okay, so if you guys can remember, we used one of our Docker images earlier on. That is this file. So it is a simple application that we have written. In this application, we have developed a very simple application that's basically gonna show us what we're gonna be building in this scenario. In this scenario, you guys can see that we are using this simple Node.js application. We are running a multi-stage build from the base stage right over here. What we have done is we have taken this base image and run some test against it. And after the testing is done, we use the test base image and we're going to do some builds. And once the build is done, what we're going to do is we're going to deploy the application. So this is what the basic Docker application is all about. So you guys can see there is a one particular step in here that what we do is running test. Okay, so we use this npm run test command to run the test against it and see whether these tests are running or not. So let me explain these test cases for you. So we have a sample API, very simple web application, API application. In this web application, there are few what we call test cases. So writing test cases, depending on the library framework or depending on the language that you're going to use, is going to be different. Okay, so for example, that right now in my in this simple application, I am developing a TypeScript application, which is essentially something going to be in JavaScript. Okay, so when we are writing test cases against JavaScript, okay, there are certain libraries, certain frameworks that help us to write these test cases. So in this scenario, we are using a test library called Jest. Okay, for writing unit test, we are using a library called Jest. So this is because we are using JavaScript or TypeScript in this scenario. But if you're using any other framework, any other library, any other programming language, it's gonna be different for your use case. So for example, if you're using Java, then your testing library for unit testing, writing unit testing, it's going to be probably one of the famous one called JUnit. Okay, so JUnit, one of the popular frameworks for writing unit test in Java. So you can use that to get in order. And if you are using something like Python, there are unit testing libraries like PyDocs. Okay, so based on what frameworks that you're using, the library that you're using, the use case that you're going to be using, the library will be different. Okay, so if you're using something like Android, then you will probably go something like Kotlin. So Kotlin use the basics of Kotlin is going to be using like JUnit as well, since sorry, not yes, JUnit, since everything that is in Kotlin Java is going to be something like JVM base. Okay, so you can use those things. But the concepts behind writing unit test, the concept behind writing all these unit tests and application tests is going to be something similar. So what we're going to do is we're going to see how a normal test case is going to behave. Okay, what are the test cycle, life cycle events? So you guys need to know what are the test cycles events that we're going to be going on, and we will apply those things in here. Okay, so one thing that you guys should know that out of the box, these things are not going to be working, right? If you set up a bare bone project, something like yourself, you are getting all the not dependencies and everything. Sometimes what will happen is these test cases won't be running as out of the box. Okay, you need to set up a test suite. In this scenario, we need to set up just in order to get testing running. Okay, so we need to make sure that we have that configuration done. But luckily, the frameworks or the code generators that we are using, they have pretty much put in the just presentations or the configurations that we need to run just right in here. Okay, but most of the time, if you want to start from the scratch, of course, any framework that you choose, they have instruction how you're gonna make this happen. But for now, I'm gonna just assume that we have set it up. And by the way, the framework that I am using, it is also already have set these things up, so no worries there. And one thing that another thing that we need to think is based on the frameworks library, the way we gonna be organizing our test cases is gonna be also a little bit different. For example, sure, in a Node.js application, most of the time, right alongside the logic itself. So this is a service. Okay, so this is where like business logic's going on. So alongside this, we have the test. Okay, so how we gonna know that? So if you guys can clearly see that the file is called app.service.ts. Okay, so this is the service that we have, and the next thing is what we have is the app.service.spec.ts. Okay, so you guys can see the spec name or the we call the file format there. So this indicates that it doesn't have like a rule of, it's like a rule of thumb that if you have a service or if you have a test case to be written against a file, we have the .spec.ts file right alongside. So we will make sure that this test case is belong to this service. Okay, that's a rule of thumb, but we can write anything for other than else. But why do we make this confusion? To avoid confusion, this is the test file and this is the actual implementation. Okay. Sorry. So let's look at the application or the business logic that we have in here. Okay, so in here it's very simple, what we call a business logic. Okay, so in this business logic, we have a method called get data, and it's gonna return a message. It's gonna be in type string. So in this scenario, what we will be returning is hello API. That's the message that we're gonna be sending back. So since this is a really simple test case, what we will do is we will write some test cases and see when we call this get data method, whether it's going to return this accepted JSON file and whether it is containing this hello API message on it. Okay, that's our primary goal for testing this out. Okay, so remember when you're learning testing, when you're thinking about testing, testing is not always about testing out the actual implementation, or in this case, the actual value that we should get is hello API. Okay, this is the actual value that we're going to be getting. But sometimes we have things like negative test cases. Okay, so sometimes we need to make sure that it is not sending something else other than that. So for example, we can test when we call the get data method, whether it is returning hello API. And the next thing that we need to test is when I call this API, when I call this function, it is not sending Randika, how are you? Okay, that is like a negative test case. Okay, so we know for sure that it is going to send hello API, but we should also expect not to send that is not supposed to send. Okay, so you guys ask why we going to do that? Why we going to be checking like a scenario that, obviously when you see it, it's not going to send it anyhow, but why do you want to check it? So the reason behind is some changes that we are doing, we might break this. Okay, so we might break this on some occasions. In here, it's really hard to break in this scenario. But believe me, when we are writing actual logic that makes sense, the code is getting complex. There are like so many ways that this thing can go wrong. So in those scenarios, what will happen is one of the negative scenarios might trigger. Okay. So if a negative scenario triggered in, then our code is expecting, our code might be doing something it's not supposed to do. Okay. So we need to make sure that it is not happening. Okay. That is one of the things we need to make sure that that's how the API is tested out. Okay. So we'll see how we can write positive test cases, negative test cases. Okay, there are a lot of things we need to discuss. So another thing is when we are writing these test cases, this is something you will see oftenly. So this is like framework dependent code. Okay, you guys can see there is a decorator, what we call in the TypeScript. So in order to this to work, the framework need to be set up. Okay, so when we are writing our test case, the first thing that we need to do is make sure the environment or the correct methodology is set up for us. Okay, but sometimes, most of the time, if you are writing good unit test, okay, you do not want to inject, or you do not want to have the environment set up for you. But we will see this in action, why these things are needed, because sometimes it's not always about testing the logic. Sometimes we need database connections, or we need to set up everything that it has. So we will see why this kind of thing is important, like setting up the framework and how we're going to do that. Okay. So first thing that we need to do, we need to worry, or we need to at least learn. We need to learn the things called test suites. Okay, test suites. So in here, the test suites that we have written is what we call a test suite is like collections of tests. Okay, so we have smaller tests. By collecting them together, we will create a test suite. Okay, so we will create a test suite. So you guys can see we have something called describe in here. So describe is what we call a initialization or starting point of a test suite. So we are creating a test suite, and the test suite name is called app service. Okay, so we can give a name that makes no sense. App service test. Okay, so whenever we are running, it's going to say, okay, we are executing app service test. And what are those things? We will look in here. So in here, what we're going to do is we have inside this test suite, we will have things called life cycle events. So not with most of the time we have these test life cycle events inside test suites. It's not often to have like those things within the test itself. Okay, so we have these test life cycle methods. So these are like really important. Most of the frameworks, like as I mentioned in Java, JavaScript, Python, you will see the similar implementation. That's because these concepts that we use for testing is going to be the same. So why? What's the what do you understand by a life cycle event? So we normally by default we have like 4 life cycle events. So these life cycle events play a major role when we are executing these tests. So you guys can see there is one life cycle event called before all. Okay, so as the name suggests, the before all life cycle events doing what it is doing is it's gonna run, or it's gonna execute whatever uh, within this block, or within this code block, and it will execute before all of these test suites are executed. Okay, so we have test in here, so we have another test suite within the test suite, and within this test suite there we have test case. So before any of these things gonna execute, if anything's gonna happen, the before all lifecycle event will fire on. Okay, that will be executed. So whatever within the section over here will be executed. Okay, so this what we call the before all is some kind of a life cycle event that is for setting up the environment. Say, for example, we need to connect to the database, we need to set up the framework, we need to have some predefined data in. So we need to have some sort of preparation for the test. Okay, so before all of these tests going to be executed, this before all section will be executed, and whatever within that will prepare, most of the time we will prepare the test case to be executed. Okay, so we will be preparing our test, we will be preparing our environment to test it out. So in this scenario, what we're going to be testing is this simple uh, class, the app service class. Within that, we will be testing the get data method. Okay, so in order to test this class, we need to make sure that we have a testable version of this. We need to make sure that we will be testing this one out. So we need to make sure we have a implementation. We have instance of this app service. We need to have an instance. So you guys can see this is a class. So we need to instantiate this class. Okay, the class is not going to be doing anything. We need an object. We need an implementation of this class. So in order to do that, we need to instantiate this one. Okay, so in this scenario, the app service class, what we can do, if you guys know Java or JavaScript or any object-oriented language, you can say that const service equals new app service. Service. Like this, you can instantiate a new instance of this app service class. Okay, but we can do like this, but the problem is this is something we call a framework dependent code. Okay, this is not an ordinary class. It is depending on the framework. Why that I'm saying this has this injectable token in it. Okay, so the recommendation would be to go as much as framework less dependent, because you don't have to set up everything like that. But in this scenario, I would be I would be giving this demonstration how we can use these lifecycle events to instantiate such a framework event. Okay, so if you have a database connection, this is the place that you're gonna do. If you need to instantiate the framework, if you need to have some dummy data, so these lifecycle events are happening. So even though you guys do not understand these things, just remember what it does is it's gonna create a testing module. Okay, so this is a testing module, and we provide the instance of this service. And by providing this test instance service, we can get an instance of the service that we want to test. So this one is the service that we're going to be testing, the app service. And this section of code, just simply think this is instantiating this service. Okay. Of course, it is something similar to like this new app service, but rather than in here, there are framework dependent things happen. So all those framework dependence, these things happens and everything is get it done. So before all is like setting up the service class to be tested. Okay, it's we haven't started testing, but we are going to test this. So in order to get started, we are setting up. Okay, so that is done in before all life cycle event. So we, as I mentioned, there are like other life cycle events that we have. Okay, so one, for example, another life cycle event is before each. Okay, so before each is another life cycle event. It goes something like this. So what will happen before each? So you guys know that there are test cases, more than one test case within a file. Okay. So in this scenario, in this particular describe app service test function, we have another test suite. So within this test suite, we have another test. But within this app.service, we can have another test case. So in this scenario, it is starting with it. Okay, so we will look into this a little bit later. So I can name this test one, something like this. Okay, so I'll do some dummy test. Test two. Console log test one and test two. Okay, so within this describe test suite or within this test suite, we have a before all, we have a before each, and we have some test cases and also another test suite. So what will happen within the before each method is, the test suite gonna execute this test case, or the test runner will execute this test case. Then it will run the test case 2, and this goes on. If we have 3, it will run the third test execution. Okay, so when we are running these test cases, what will happen is before each function would be executed right before this is going to get executed. Okay, if we are about to execute test one, the before each function would be executed. If you are about to write test two, the before each function is executed. Test three, right before it, it will be executed. So why do we need such things? Is there are sometimes when we are executing these test cases, okay, the first thing that we need to remember, when we are executing test, the test should be independent. At least the unit test that we are executing, the tests, these things are totally should be independent from each other. That means if I do something in test one, okay, if I do something in test one, it should not affect test two. Okay, it should not be affecting test two. Same goes to test three. So why these things should be individual, or these shouldn't? These things should not be uh, should not be should not be executed should not be executed within this order, or why these things should be executed, or shouldn't be depending on anything. The main reason is the main reason is that the main reason that is when we are executing unit tests tend to be executing simultaneously. Okay, so while the test 1 is running, we can also execute test 2 and test 3. Okay, so if things are executing simultaneously, what would happen is if we have a dependency on test 1 after test 2 and test 3, then the correct order is mattering. Okay, but if you are running simultaneously, it can while test 1 is running, test 3 can run, test 2 can run. We can't guarantee the order. So since the order does not matter, the test case should not depending on each other. So when we are writing unit tests, we need to make sure that anything had to do with test 1 is not affecting the test 2. Okay. So in such scenarios, what we need to do is make sure that the test that we are about to run in this scenario, the test 1 that we are about to run is running at a clean state. Okay, so whatever the data that the test 1 needs, it should be instantiated. Okay, so it's like running a test case in a clean state. So we need to make sure when we are running other test cases that we have in here, all those test cases running in a clean state. So right before a test case run, before each function would be useful for cleaning up the mess that we have created. Okay, so while we are running test 1, we might enter some data into our database. Okay, we can do that. We have some static variables that we have used, we have some databases, we have some files that we have read. So anything that we have done, we can undo that. When we work on these things, when we work on the previous task is executed within this test, it might get overflow to the next one. Say for instance, within test 1, I insert one single record. Okay, in the second scenario, we will be counting the number of records. Okay, and if you are to run a test case, we need to make sure we know the exact amount or the exact value that we have written. Okay, if we enter 1 in here, and if you are checking on the next one, if you are having the correct amount of data, then this will be conflicting. Okay, the values will be conflicting. So we need to make sure whenever we are running a test case, a clean state is managed. So we are managing that clean state using before each. Right around here, we can say, okay, if you are using some variable, we can reset it. Okay, if you are using something like a database, we can clear the database. If you are writing some data if you are writing some data to a file, we can recreate the file or we can delete the file. Okay, so make sure whatever we are doing, these are not conflicting with each other. Okay, so that's the main reason these lifecycle events are there. It's not mandatory to use these things. Okay, but it is a thing that we will do. Okay, so we'll see these in action just to give you a heads up on what these are for. So before all, normally we set things up for everything like a database connection, opening a file, that kind of thing. Before each, what we'll do is we will execute each and every command that we have, and database resets of resetting the files, that's kind of things we will be executing in the before each. Okay, and we will be running these things. Then what we have is what we call another lifecycle event after each. Okay, we have another lifecycle event after each. So after each lifecycle method, as you guys can guess, okay, after each is a simple, okay, I can't name this, sorry. Okay, so after each is a lifecycle event that execute right after one test executes and before the next one starts. Okay, so we execute test case 1 after each is executed. We execute test 2 after each, we finished executing test 2, then after each executed. We finished executing test 3 after each execute. So you guys can see, we can get the after each for like if you have some clearing things to do, if you need to release something, that kind of anything, any sort of thing, we can do with the after each life cycle event. And as you might have guessed, there is another life cycle event after all. Okay, so every test within this test case is executed, the after all life cycle event is executed. So why do we need the after all execution? uh, we need this after all to release the databases. Okay, so we sometimes, we create a database for the whole application. Okay, we are creating that and we are still keeping that up. Now at the after all, we need to make sure we need to release that database connection, because uh, this is not going to be the only test case that will be creating a database connection and keeping it on. There are other test cases which will use these test connections or database connection. So in this scenario, if we do not let it go, other test cases won't be able to utilize the database and the test will fail. Okay, so we need to make sure we need to get things released at the end. So you guys get the idea. Before all, we create everything. Before each, we clear data and we prepare the data. And after each, we can also clear data. Sometimes it's not always mandatory, but after each, we can do like sending a file, or after each every test is executed, we can notify something. Okay, this is done, this kind of thing, or emptying data, whatever the things. And after all, after everything is done, after everything is executed in here, we can execute the application, or we can stop the application while the resource can be what we call released. Okay, let's see this in action. So what I'm gonna do is I am gonna just for now see the life cycle events. So I am gonna write before all. Okay, before all, and before each, and I am gonna have after each, and what we're gonna have is after all. Okay, so we have we don't have any like actual test cases, but we have test 1, test 2, and test 3, and we have some life cycle event before all, before each, after all. Okay, so I can execute these things right from my Visual Studio Code editor. Okay, there are some plugins that helps me to do this, but if not, we can use something like a test runner. Okay, so this is going to be the test runner. So if you don't see these things, just install an extension called JSRunner in Visual Studio Code if you are into this. Or if not, if you have configured everything right, you can just run your test suite by simply saying run these test cases for us. Okay, since I have configured everything, I don't need to do anything. I just need to select the test case and hit run. So the test will be running. Now you guys can see the test case logs that it is creating. So first of all, before all is executed, yes. Before each is executed, then test one has executed. After each is executed, then before it goes to the test two, before each is executed, test one, I think I have misspelled it. Let me check. Yeah, it should be test two. Close, so you guys don't. Okay, so right. Before each, test one. After each, before each, test two. After each, before each, test three. After each, and after all. So you guys can see the life cycle events are executing as they're supposed to do. And once they have done, you guys know what the actual implementation of the life cycle events. Now, for implementation wise, what I'm going to do is I'm going to have this service ready, and I'm not going to look into each and every test case that we have. Okay, sometimes we do not use these all the test cases, all the lifecycle events, but for now, remember there are, and they can be used in different circumstances. So my objective is to test the get data method. Okay, so what I'm going to do is I am going to create another test case or test suite in this scenario. It's called get data. Okay, so within the get data methods, what are the tests that I can do? Okay, and there can be tests against this class. Okay, so I am running test case against the get data method. You guys can see there is a get data method. So I'm running test cases against this get data method, but I can also run test cases against this class. Okay, first of all, whether the framework is working, that means the app service class that we need is not instantiated, or it is not working. We can check from the application, okay, whether this app service is instantiated correctly, whether it is working correctly. So let me write something small in here. To start writing test case in Jest, we use the function, or we call it, okay, this function, and we need to name our name our test. Okay, so in this scenario, I'm gonna test whether the service is instantiated. Okay, it should. Okay, normally when we write a test, we start something like this. It should be like in plain English so anyone can understand. So in this scenario, it's the same thing. So we normally say it should instantiate the service class. So it should instantiate the service class. That means before before all has done its job and the service is instantiated, we're gonna check it out. Okay, so it should instantiate the service class. So what we're gonna test in here is goes around these and these braces. So whatever we are running, it should be checking in here. Okay, so the next thing that we're gonna do is we're gonna do something called assertions, or we're gonna do some checkings. Okay, so we are saying that it should instantiate the service class. That means we should have an instantiated class. So that is our expectation. Okay, And to validate our expectation, we need to have some values. That means my test case in this scenario is going to be checking whether the service class, the class that I have declared, is not an empty one or a null one, or it is not undefined. My test case is to check whether this is working. That means the service is instantiated without a framework issue. I can start testing the service class. So my intention is to check whether this is null, undefined, or not working. So it should instantiate the service class. So what I'm going to do is I am going to use something called expect. Okay, so what I am expecting, I expect service. Okay, I expect the service not to be null. Okay, that means what I am expecting is this service not to be null. So you guys can see it's like writing plain English. Okay. So my expectation, if my expectation is right, if my assumption is right, then the test case will pass. If my expectation was wrong, then this test case will fail. Okay. So I can run the whole test suite if I want, or I can run the single test case that I have written in here. Either way, it works. So I'm going to be testing out this one. So I can say it should instantiate the service, and my expectation is I expect the service not to be null. So it should be null. Now you guys can see this is null. This is basically a null object at this point. So my expectation at this point, it should not be null. Let me run it. And there you go. It gives us a green mark. Should be instantiate the service class. Yes, that is pass. That means my test case is pass. So I don't have to worry about being it now. But what I'm going to do is I'm going to make this before instantiation class. So the instantiation that I did in the before all, I'm going to comment that out. That means this service is going to be null. Okay, the service is going to be null because I haven't instantiated it. I haven't created the instance of it. Instantiation is not there. So it should be null. Now my expectation in this test case, I expect this service not to be null. Okay, it's not to be null. But as you guys can see, since I haven't instantiated, my test case should fail. Okay, there you go. So it is saying the app service test, it is passing. Okay, so that's one thing, that why we should write test cases. So you guys can see, even though I haven't done the initialization, my testing is passing. Okay, so these kind of things is pretty normal, even though we expect that to be not to pass, but it is passing. Okay, so why this is happening, why this is not the thing I expected, why this is happening? Let's debug this code. Okay, let's debug this code. It is simple. So if I want to debug this code, if I want to debug this test case, why this is happening, why my test case is failing, I can do something like use print statements and all those things, but something like this, I can say print and you can get the work done, console log or something like that. But my recommendation is to put a debug point. We can see a debug point and see what's going on. So the line that I want to debug is probably in here. So what I'm going to do is I go to the line number. If I go to line number, you guys can see there's a red mark coming on. Okay, red mark coming on here. If I click on it, it will be highlighted in a brighter red color that indicates we put a breakpoint. So what do you understand by a breakpoint? When we start debugging this code, when we start debugging this code, when we are trying to find an error, what will happen is when this when this is the execution point, or when this line to be executed, the execution halt and give us a reference to this section. So we'll see how this goes. So if I run this, it will normally run. Okay, it will be normally run. But if I click on the debug button right around here, you guys can see that it is attaching to the debug. And yes, now if I trim down a little bit here and there, the debug point is at wrong point, but okay. Now you guys can see the debug point is at the breakpoint. So there is this yellow thing that indicates, okay, we are at this point. Okay, so now if I hover over this, okay, if I hover over this, now you guys can see the value of the service. Okay, the value of the service is not null but undefined. Okay, the service is undefined. It is not, it is the value of service is undefined. Okay, but what I am checking is whether it is null. Null and undefined are two different things. Okay, null in the sense it is empty. Okay, that means the value null should be there, but undefined in the sense we haven't even defined it. We haven't even considered it having it here. So the service at this point is undefined, but we are checking whether it is a null. Okay, so our test case is wrong, so we need to update this one. Okay, so let me, what I can do is I can stop this debugging session by clicking on this stop sign, and I can update to be, okay, not to be undefined. Okay, so now my test case has been updated. My test case is I expect this service not to be undefined. Okay, it shouldn't be undefined. Let me run it. But as you guys can see, the test case fails because I expect the receiver, that means the service, not to be undefined, but what I received is undefined. So my test obviously fails. But if I uncomment this, the initialization, if I undo the or uncomment this initialization, that now will happen. This service is defined. Okay, that means it has an value. Now if I run this test case, should pass. Yes, it is passing. Okay, so make sure when you are running the test case, it is not always, as I mentioned, we can expect, okay, this is going to be a null, but our test case is going to pass anyhow. Okay, you guys can see that I was expecting it to be null, but actually, whether it is null or not, the test case was passing. Okay, so we are giving a false test case. Okay, our test case should be updated. It is not to be undefined. Okay, it shouldn't be undefined. So that my friends, remember that you need to make sure that it is the correct test case, the correct thing that you are testing when you are writing unit test. Okay. All right. So this can be done in another way, to be truthy. Okay. So to be truthy in the sense, if you look in here, when you use, you don't care what the value is, you just want to ensure the value is true in Boolean context. In JavaScript, these are the falsy values. So if it is false, then the test case will fall. If it is 0, false, empty string, if it is null, undefined, whatever these values comes in, this test case will fall. Okay, so it should be truthy. That means I expect this service to be truthy. That means this should be either, it should have a value. It should not have these values: false, 0, empty string, null, undefined, or none, not a number. Everything else is truthy. Okay, so you guys can see we can be safe. Either we are checking on null or something like that. Sorry, or we can use something like this checks to make sure that is correct. So if I run it again, it should be okay. All right. So if I remove the instantiation, and it should fail because of undefined. Yes, you can see because if undefined, it is failing. Okay. So there are few keywords or few methods that we can use for testing, like not, we can use the to be undefined, okay, or we can say not dot to be undefined, so it is the negative case, okay, not greater than. There are a lot of other things that you can check: not to be undefined, not to be truthy, to be null, be then greater than or equal, whatever the value or the whatever the things that we need to check, there is a method that we're going to be doing that. So I'm going to say to be truthy. Okay, to be truthy. That means the service, the class should be instantiated. That is my expectation. All right. So this is our first test case, that is checking whether the service is truthy. That means the service has available. Okay, any questions up until this, guys? Anything that need clarification? So remember these things: the life cycle events, you writing test cases. It seems to be like coding, but it is, when you look at it, it is really simple. Okay, so if you guys are like into development, this is a must. Okay, if you are a developer, this is a must thing that you should do. Okay, all right. Next thing, I'm gonna create another test suite. So within this service, within this app service test suite, I'm gonna create another test suite for testing out app data. Sorry, get data function. So I'm gonna be testing get data function. So I'm gonna just have it. So within this test suite, we have, you can see that there are no like no what we call no life cycle methods within this test suite, but it can be there as well. But since we have initiated everything, we don't need a life cycle events in here. If you want it, you can have it, but if you don't it, you can just leave it alone. Okay, so you can see the lifecycle event that we have, sorry, the test case that we have run, it should return hello API. Okay, that is the expectation of our application. So at least this is the description, and we expect the service. And if you call the get data method, it should return something, right? That to be equal to hello world API. So if you look at in here, you guys can see that message is equal to hello API. So in here, what we are saying is expect, if you call to get data method, it should return something and it should be equal to hello API. Okay, so this is the expectation of our test case, and we should run it and see whether it is working. Yes, it is passing. Whether with what's going on in here is completely fine. Okay. So the best thing about it here is that we are writing very simple test case. Okay, so we say for instance, how we gonna make sure this is very useful. So for some reason, I am developing my super complex application, and all of a sudden instead of saving in my computer, it's like Command S, but for Windows maybe it's like Control S, and uh, with one of my fingers going up, I accidentally press S, and I thought, okay, this was a change that's supposed to happen, and I am trying to send this code. Okay, so there are no errors, there are no compiling errors. Okay, so what I'm going to do is I'm going to push this code, but before I push it, I run my test cases. Okay, so when I'm running my test cases, all of a sudden it says expected and equal to be expected, so DP equality. So the expected message is hello API, but accidentally, or from my change, it is sending APIs. Okay. So in this scenario, you guys can see it is like it can be like a small thing that we have detected. But remember, in a production level application, a single name, single file, single thing that we do can break the system. Okay. So in order to avoid such a thing, always write test. Okay, now I know, okay, accidentally I have put an S, and I need to make sure everything runs perfectly. Yes, everything passes. So uh, my code, the code that I have written, is perfectly working as expected. Okay, and as I mentioned earlier, okay, so this is like the best case scenario that can happen. We should also have things like negative scenarios as well. Okay, so for example, I will copy this. It should return by test case is it should return it should return error on it should what we call, since we are not passing anything, that's hard to say. It should not return hello run beacon. Okay, so first case is the positive scenario. It should run hello. It should return hello API. And the second test case, it should not return hello run beacon. Okay, so I can say hello Randika. Now this is not equal. Okay, this is not equal. It should be deep equal. Let's see. Okay, but anyhow, let's say the first test case check the correct thing. The second test case is checking whether it is not giving something unexpected. Okay, so if I run this again, then you guys can see it should not return hello Randika, that it does not. Okay, so there are like, this is like very small demonstration, but when we are talking about really complex things, it will make more sense to have uh, complex test cases in here. So if you look at the code itself, the code that you have written is like in a readable state. It is like 1, 2, 3 lines of code. The actual logic is 3 lines of code. But if you look at our test case for that, okay, it is more than 6 lines. Okay, then this is also a very small one that we are using. A very small thing that we have done. So altogether, when we are writing test cases, be more expectative that the logic, if the logic is 2 or 3 lines, the test will be like more than 10 lines. Okay, so more than you write code, the actual implementation, the most thing that you'll be writing is a test against that. Okay, so that is the reality, that is the expectation. So make sure you write these test cases. Okay, so you know pre-handly if anything that you have done is changed, and it might gives you a hint. Okay, you have changed this and now it is not working. Now fix it. Okay, this kind of scenario is there. So that would be really helpful when you look at in that way. So we have the prevention part. We can prevent any errors that be happening. And there is the section where uh, there's the advantage of giving confidence on your code. Your code is well, it's tested, and we can assume that if there is no big changes, it will work as expected. It will work in this manner for a bit of time. Okay, so we can be sure that our application is running smoothly. Okay, we have that confidence. We can sleep at night knowing that the code that we have written is at least expected to working perfectly. Okay. Yes, there are scenarios where even our test case might not have get everything in order, but we have like little bit of comfort that we have something that is going to be good. Okay. All right. So there are two advantages. The next advantage that I'm going to teach while we are writing a test case is um, the coding experience. How the coding experience will change when we are looking into such application. Okay. So let me write. Just give me a second. Let me get a bit of code that works. Mhm. Okay, I think I have something in here. No. All right. I'll write a function. Okay. Then we will see what sort of test that we can run. You guys need to help me with this, and we'll try to run the test case together and get some things done. Okay. All right. My test case would be uh, let's take it simple. Okay, must as simple as possible. Um, yeah. The test case is get user details. Okay, so simple test, simple method, and it is expecting a name and an age. Age should be something like a number. Okay. So what I'm gonna do in this scenario, I'm gonna do is I'm gonna return my this one. So I'm gonna concatenate the name file file and based on the age switch, and let's write a simple if in here. Age is greater than 10, I would say, and have let age string something like it should be something like old. Okay, if age is greater than, let's say, 30, age string would be something like I am wise. Age string is but no use. Okay, that's can be I you are for the age. Format that code. Okay, so this is a simple function, right? So anyone care to explain this? Anyone in here? I'd like to explain this code. It's really simple that I have written. Raise your hand if you like to explain this. How the brave enough? Who's going to explain this? It's a very simple code, the get user detail function. Jairu, can you explain? It's like, reading, you don't need to know the everything, but you can understand what is going on. Pavani, can you explain? Just give it a try, okay? Don't be worried about this. Anyone? Tanindu Kamagi? Tanindu Lakmal? Anyone? Who is brave enough? I mean, come on, it is not a big thing.
It's getting the user's name and the age.
Yes, correct.
After that, in the loop, if function, it's
Condition.
checking the age.
Yes.
Condition. It's
Uh-huh.
checking if the age more than 30. If it is more than 30, it will the variable will change to I'm wise.
Okay.
Age is string, I think.
Then at the end,
At the end, the value will return the name.
yes, I
Return like hi, the
yeah,
name, and
you are
you are, and if it is more than 30, it will print return as I'm wise.
yes. If not,
If not, it will return as import.
I'm more. Okay. So thank you, Jairo. So that's the basic idea, right? So we have very simple function, right? The function is working. You guys can see it's not a big thing. So if I put an age and number, it should return something and it should show something like that. Okay. So you guys can see it's fairly not complex method. Okay, but let me show if I write a test case against this, what will happen? What will make these things little bit hectic? Okay, so the first thing that I'm going to do is I'm going to go to get detail service a new test suites. Okay, I'm going to say describe. I'm going to be describing get test suite, get user details, and I'm going to go in here. Okay. So first test case that I'm going to write is it should say I am, let me put it in quotation mark. So double quotation in here. Okay. I am wise. It should say the exact thing. Let me put. It should say, hi Randika, you are. Let's keep these. You are. Let's simply say, you're wise. You are wise or you are old. Okay, you are wise. So the exact thing that I am expecting, hi Randika, you are wise. This is my expectation of the test input. So tell me what are the parameters that I need to make sure this is if I want to pass this, what are the things that I need to do? So I should say expect service get user detail. So in order to pass this, the first value should be Randika. And if I want to be wise, I need to be like at least 30, 32. Okay. And I can say expect to be equal I can say simply EQ to equal. This is the text that I am expecting. Hi, Randika. Hi, Randika, you are wise. Okay, so let me format that. So to get hi Randika, you are wise, I need to provide Randika and 32. Okay, and let's run it. I think I have missed expected hi Randika. Okay, I'm missing. Yeah, so it should say hi Randika, I am wise. Okay, this is working. And the other thing that we need to test is hi Randika, you are old, and I need to pass something like 12. Where let's see. Hi Randika, you are wise. Received, you are old. Sorry, okay, this should be old. Let's run it. Yes, it is working. It should say hi Randika, you are old. So our test case is working. Our application is working as expected. But the problem that we see in here, okay, the problem that we are seeing in here, the method that we are going to be testing, the method that we are testing in here, it has something called a complex code. Okay, a complex code. So we do not know the logic that is going behind with the if logic and everything in here. Okay, so what we call these things as in here, the manipulation is okay, this manipulation is fine, but for some reason, if this logic, if this thing need to be changed, if for some reason the age checking part that we are supposed to do, if we want to check that out individually, how we going to do that? How we going to make that happen? Okay, so having these kind of this kind of code, yes, certainly it works. It is working, but the problem is I can't test the logic. I don't know what's going on with the age limitation. Okay, so for instance, I have another use case that I will add. Let's say else if age is greater than, let's say, 40. Age is greater than 40. You are handsome. Okay, so we're going to be having 40 in here. So our expectation is let's say if it is greater than 30, it should say wise. Else if it is more than 40, it should say handsome. Let's say for like 43 in here. So if I run this again, you can see there is obviously the logical error is here. Okay, you guys can see if it is more than 30, if it is wise, so else if is not going to be executed. Okay, so if I put in another if, what will happen? Let's say I run this and it is getting failed. Okay. So the problem in here is the problem in this code section that we have in here. The logic is too complex or too much responsibilities in this function. Okay, the function is getting crowded. Okay, there will, if there is something else to be added, let's keep this let's keep this one for age, and say for instance if name if name equals to Nuwan, okay, and we would say age string, no, not the age string, at least the name is Nuwan Hapugod, okay, something like that. If the name is Nuwan, then the Nuwan Hapugod, the name will be Hi Nuwan Hapugod. So the logic is getting little by little. Believe me, when we coding, the method is getting too complicated. Okay, the name, now there are main name manipulation, there are age manipulations, and there is the what we call the concatenation manipulation. So there are a lot of things going on. Now you guys can see the code is getting more and more complex. Okay, our test case, what will happen is our test case will be overpopulating. It's gonna have a lot of things that we need to write. The test case is gonna get messier and messier. Okay, so how we gonna address this? How we gonna address this in this scenario? So you guys can see the test cases are gonna get much more complicated. So if I put one in here, then that will produce something else. And if I put age more than 40, then it will be something else. Then the test cases that I am about to write, that's test cases that I am about to write for the user details is gonna get way more complicated. Way more test cases need to be run against so many different things. So this is like a very simple thing, okay? But the code is, the test is getting way more complicated, and the code is getting way more complicated. The clear indication, my code is not in a good state, okay? You guys can see, okay, this is fairly a small thing. This is fairly not a huge thing, but how do I get a matrix? How do I know that my code is getting little bit out of hand or little bit of uh, hard to manage? Okay, the first indication is your test cases, that your test cases you are about to write, or when you are writing test cases, it's gonna get way more expensive, or way more what do you say, crowd. Okay, these things gonna be really hard to keep even track of. Okay, so what we need to do is, so if you are thinking, right, these test cases indicates that my code is not into best practices. It is not into the way or the expected standard that we supposed to keep. Okay, so the first thing that we will gonna is when this kind of things is indicated, when this kind of application is giving us the headache, then we need to think about our code need to be structured in a different way. Okay, our code need to be structured in a different way. So that with that indication, what I will do is I will say, okay, there are age-related things that need to happen in a separate thing, and there is a name-related thing that we need to happen in a different thing. Okay, different way. So what I'm gonna do is I am gonna refactor my code. Okay, I'm gonna refactor this code in order to make more useful. Okay, so I will say I will use get age function. So I will give the age So a number in here, and whatever the age related thing, I will put it in this function. Okay, so I'm going to say let age string, and I'm going to return age string. Okay, so whatever the age related logic is in here. Now this function, the function that we have, get age, is only thinking about age related logics. Okay, whatever the age is there, then we can focus on in here. Okay, so what we call this approach is a single responsibility, so it is only thinking about age manipulation. Okay, and the same way, what we need to do is we need to age string, remove all these things, call this dot get um, get age. Get age, and now it's supposed to. Okay. Const here. Let's say const. So now anything related to age is going to be in this function. Okay. Same goes to the name. Okay. Get name, and I can say name. It's going to be a string. Anything related to name can be here. I can say return name, and I can say const dot. I can say name equal get name, pass the name. Okay, so now my code is little bit easy to manage. So anything that related to age is in a different function. Anything that related to the name is in a different function, and anything that related to the all of these things in here. Okay, so we have introduced a new function, get name. Then what I can do is in my spec file, the service that I'm going to write, I can write a describe block to get name. Okay, the function get name. So name related manipulations goes in here. Okay, name related. Okay, then there is age related ones. Age, get age. Okay, age related. So rather than me focusing on the things that I should concatenate in here, now age related things will be in a separate function, and name related things will be in a separate function. This function is just gonna give us a name and a string, so it will be just a simple mechanism that we can use to check the value on it. Okay, so we do not need to specify a lot of test cases because we have tested out the age related things in a different test suite. In this test suite, we are following all the things that is related to age. Okay, and we are testing all the related things in name function. So anything that changes in here is going to be affected in here. But in this scenario, in this section, what we're going to be checking is only the getting details. So our test suites will be fractured out, or will be like into smaller chunks. And our code now, it is more readable and more manageable. Okay, so you guys can see by introducing test cases, by introducing those kind of things, what will happen is our code will automatically improve. Okay, so our code will automatically improve its quality. Okay, so when you used to when you are used to keep in your mind, okay, I need to run I need to write a test case for this scenario, then automatically, okay, without thinking that much, your coding will be different. Okay. Okay, you have in your mind, you have this you have this concept. Okay, I need to write a test case. If I am going to write a test case, this method looks ugly. This is not well organized. I need to refactor this code. And since that mindset is with you, you will be automatically writing good test cases. Okay, you will be writing automatically good codes. Okay, so when you practice these testing within your application, your coding quality improves as well. Okay, so make sure do not write only the code, the logic that it needs, also write test cases. So by doing that, you improve your quality of your code as well. Okay, that is something you guys need to remember. So write some test cases for you guys and see the difference. How you think about the code is gonna change when you see the code and you see the logic. Okay, this logic need to be changed because I can't write a test case against this. Okay, so this is like a very, very simple scenario, but in the long run, you will see that this is something really, really good and really simple way, effective way of coding. Okay. All right. Next thing that I need to, so I have top 3 advantages writing test cases. So remember those things. The next thing that I need you guys to work on as an assignment is to a concept called mocking. Okay, so the assignment is what do you understand by mocking? Okay, and what mocks is trying to help. Okay, so that is something that you guys should do. So in testing, mocking is something really important that you need to do. So think how mocking helps. What are the testing frameworks or mocking frameworks available on any of the framework or language that you like? Okay, so uh, have a look around mockings and what do you understand by mocking and what are you trying to achieve with mocks? Okay, what are you trying to achieve with mocks? Okay, that's been said. We looked into testing. We have written some tests. Let's see our tests are executing. I think there's a failed test. This one. Okay. Yeah, so our tests are executing, good for us. And the thing is, when we write this unit test, we incorporate this in our Docker file in this scenario, in this our Docker file. So before the final product is pushed into the final production environment, we run this npm run test. So what this code is doing is it's going to run all the test cases that you will find. So there is all the specs files in here. There are a lot of specs files in here. It will run all these specs files and see whether our code is working as expected. Our test cases are passing. Everything is working fine. And once it is done, our application will be pushed. So if somebody comes into our code and try to break something, it will be detected, at least known test cases. Anything like really odd or a breaking change would not be detected. Of course, not everything that we can't expect everything to be covered in test cases, but there are softwares that hint us whether we have written enough test cases. Okay, so those are the testing tools that we call test coverage. Okay, there are tools that says okay, I have looked into your code. You have 10% of test coverage into your application. So make sure you cover up, you write test cases for these and these methods. So it's indicate, okay, this method need to be tested, this method need to be tested. So there are test coverage tools. Okay, we can get the help of test coverages, and we can with the help of test coverage, it will point out these methods, these classes need to be tested, and with the help of that, we can write missing test cases. Okay, for some reason, if we did not write a test case, it will be written. We can write those test cases without without looking at everywhere where we miss test cases and all those things. We can simply look into the test cases, and we can simply look into the test coverage report and see whether it is there or not. And another thing that we need to do is a concept or a programming mechanism that we can practice is or a way of programming, I would say, is going with test-driven development. Okay, so all the time that right now what we have done is we have written the logic. Okay, we have written the logic and we written the test case afterwards. Okay, so first thing we write the logic. The second thing that we gonna be writing is the test case. But in test-driven development, we do the other way around. Okay, first we write the test. Okay, we get the test. We do not write any implementation. At first. Then first thing that we do is we write the test cases like this. It should do this. It should do that. It should be like this. It should be null, something like that. We write everything before even writing a single logic. Okay, then the first thing that we do is in TDD or test-driven development, we execute that test. What should happen? Since we do not have logic, since we only have the testing case, every test case should fail because we do not have a logic and we are trying to test it out. And since there are no logic, then the test should fail. But that is expected thing, right? Why do you might ask, okay, you don't need to even ask. The first time when you are writing, first time when you are executing your test without any logic, of course it should fail, right? There is something obvious. Why do you even do that? The main reason is the idea behind the initial test run to be failing is that if for some reason one of those test cases pass, then what that indicate? You have a false logic. Okay, you have some sort of false logic that would break the system. Okay, then you can investigate without any logic how these test cases are passing. Okay, how these test cases are passing. They should be failing, but they're passing. Okay, so that might be some sort of magic behind it. So we need to investigate that. Okay, that's the mental behind the test-driven development. But there are some issues with test-driven development, especially the practicality. Okay, the main reason behind that test-driven development is little bit hard to follow or hard to implement. Is that we need to know the logic that we are going to write. Okay, so the requirement, if the requirement is not 100% with us, we can't write the test, right? The requirement should be there, and with the requirement is completely there, then we can write test cases. But the problem is most of the time, like I haven't seen a single project in my life that the requirement is solid. Okay, the requirement changes due to customer inputs, due to unforeseen things. So the requirement is always, shallow. it's a trend to change. The customer would say, okay, this is not what I meant. This is not the color I want. Every time it goes. Okay, even some application logic change, it's happened. So you don't expect the requirement to be solid unless the requirement is 100% there. What will happen is the test case won't be able to run. So in order to make sure that our test case is actually running as expected, or our application is like 100% testable, TDD sometimes, or test-driven development, is not practical, just because of the requirement being changed here and there. Okay, so that's something, but you guys have to remember that. Okay. Another note that I would like to add, we will be discussing end-to-end test on our next lecture. So you will guys see how we can automate a lot of things. So this is the unit testing that we have done today is mainly focusing on developers. Of course, any QAs who would be interested in doing this. This is the recommended day of, I would think. The main reason behind that, human errors can be very tricky. Okay, so you can't test everything every time. Manual testing is a little bit hard. Okay, you're gonna miss it. Sometimes you're gonna miss some logical changes. So as a QA person, if you can write these kind of tests, you guys can see it's like write in plain English, right? So it's going to be really interesting if you try that. But mainly remember, it's the what do you call, the responsibility of the implementation, the people, the programmers' responsibility to make unit testing works, unit testing happens. Okay, so keep that things in mind. All right. We'll discuss E2E. Any questions up until this, guys? Okay, if not, let me stop sharing and stop recording.